All right, everyone. So in this video, we're going to go over our transformation rules and look at a bunch of examples of the things that were giving us trouble or sometimes a little bit tricky. So here's a general overview of what each of our numbers are doing. So I have my parent function here. Remember, this is applicable to any of our parent functions, not only the quadratic one I have here, right? So in general, we said if I put a coefficient in front of the function, or in this case, in front of the x, that's going to be either stretching it or shrinking it. So stretch, we said, if you have a parabola and you're stretching it away from the x-axis, it becomes narrower, right? So that would be a vertical stretch, like a rubber band if you're stretching it away, versus if you're shrinking it, then it's going to become wider. Okay, and we said this makes sense because it's less than, the value is less than 1. I don't care about negative, that's just flipping it upside down, right? The number itself is less than 1, so like 1/2 or 1/5. Basically, you're taking half of each x, so each x is going to be half as much, so you're going to become you're going to get a wider parabola. Okay, and then with the h and k, we said that's going to be shifting it either horizontally or vertically. So the h stands for horizontal, right? And then for this one, we have to say, so if I'm shifting it right on the x-axis, right? So if I'm going right on the x-axis, that's a positive number, right? So if I have a positive 5, so let's say my h is 5 units to the right. Notice when I put that h in the equation, it's going to show up as x minus 5, right? So we said this sort of works the opposite way. So x minus 5 is, since h is positive, it's going to be moving right on the x-axis. But if I want to move it left in the negative direction, so if my x, for example, so if my shift is, let's say, 2 units to the left, so back 2 units, notice when you put a -2 in here, the double negative is going to make a positive. So x plus 2 is shifting 2 to the left. So in the equation, it sort of changes signs because of that minus. So that's sort of like the opposite of what you would think intuitively just by looking at it. And then the k we said is pretty straightforward. If you add or subtract at the end of the function, so take your entire function and add a number, subtract a number, that's going to move it either up or down. So plus 3 will move it 3 units up, minus 7 will move it 7 units down. So that's our vertical shift. All right, let's look at a few examples here just to start describing, and then we'll look at some equations on our own. So for the first one, we just want to describe the transformations here that are happening here. Okay, so first thing I notice is that we have a negative in front, right? So if you remember, a negative is going to reflect it across the x-axis. Right, so we have a negative, so there's absolute value, so we could shift this. So you have an absolute value here. So that negative, first thing it's going to do is it's going to shift it. We'll do our transformation in green. So we'll shift this, reflect it across the x-axis. Okay, once that happens, it looks like we're moving it. So this will be 2 units. Since it's negative, that means this is a positive 2, so that's going to move it 2 units to the right. And then the 8 is going to move it 8 units up. Okay, so it's going to be the same V shape we have over there, but we're going to move it 2 to the right. So 1, 2, and then 8 units up. So it's going to be all the way up here at 8 somewhere. It's going to be the same exact upside down V. And we'll look at graphing at the end, but that's basically what it's going to look like on the graph, 2 over and 8 up. Okay, if I look at this second one, first thing I see going in order here, so following sort of the order operations, because this multiplication do that before the addition subtraction, right, in PEMDAS. So the first thing I see that's happening is this is going to be a vertical, and you should know that that's going to be a vertical shrink since it's a half is less than 1. Okay, once again, I go flip it upside down, it still would be a shrink, just upside down. So it's going to shrink it, which makes it more wider. Okay, so after I make it a little bit more wider with that half, then it looks like we are translating it. I didn't write it with the first one, but you should either write translating or sliding. Shifting is okay too, but I like translating or sliding better. So this will be 1 unit. Okay, so note this is a positive one, so that means that came from a double negative, right? Since it's x minus 8, so x minus, so my h here is -1, which means it's going back 1, so left 1 on the x-axis. Okay, so negative on the x-axis is backwards. So 1 unit left and then 5 units down. Okay, if you minus a 5 at the end, that's just going to move it down. Okay, so you remember what the absolute value looks like? Well, Remember, you're just taking the absolute, so sketching it should be pretty easy. You're taking the absolute value of the input, so absolute value 0 is 0, so 0, 0, square root. So square root of 1 is 1, so 1 comma 1. And you have to get the next perfect square is 4, right? The square root of 4 is 2. So to get to the next integer of 2, you have to go all the way to 4. So we said it looks sort of like this. Okay, so when you sketch this one, each of the inputs are going to become, you're multiplying by half, so half as much. So this point will be half as much. This point will be half as much. This point will be half as much. So it's going to become wider. And then you're shifting it 1 unit left and then 5 units down. So it's going to look something like this, a little bit more wider or flatter down there somewhere. We'll look at exact sketching at the end there. But one thing I want to stress particularly is the order. So the order that you're doing the transformations is important, because if you switch the order, that's going to make an entirely different equation. So for example, looking at this first one here, so we have our parent absolute value function. Okay, so we want a reflection in the y-axis followed by a translation 3 units to the right. Okay, so remember for reflections, if you want to reflect it across the x-axis, you make the other one what? So you make the y negative. So y is the same as f of x. So you want to make the entire f of x negative. Okay, and if you want to reflect it across the y-axis, you make the x negative. So you make just the x negative. Okay, so you sort of just make the other one negative. So if we're reflecting it in the y-axis, that's this one, we want to make just the x negative. So the first thing I'm going to do, I'm going to call these, it says call this g. First thing we're going to do is make just the x negative. Okay, so it's important here, and I'll stress this a little bit. Since the square root of an, if I take the square root of negative, I'm just going to get positive, right? So if I could sort of factor out a -1, so I could sort of separate this. There's invisible -1 in front here. So square root of -1 would just be a +1. So you could sort of get rid of that negative. And you'll see why. I'll put this on a graph in a second. Factor out that negative first. Okay, then if I want to translate it 3 units right, I need to -3. Remember, I need a -3 to go left and right. I need to left and right, I need a -3 on the inside. So physically next to the x. Okay, so inside, I'm going to do a -3. Okay, so this would be my resulting function. So if I look at this on the graph, so if I were to look, let me just put my absolute value of x here. Okay, so remember, it says we want to reflect it across the y. So let me put just a copy here. So if I reflect it across the y-axis, notice, well, it's symmetric. So if I reflect this across the y, this point is going to map on here. This point is going to map on here. It's not changing anything. It's right, just going to go onto itself, because it's this will go here, but this will go here. So it doesn't really change anything. But then if I want to follow by a translation of 3 right, notice if I do -3, it shifted it 3 to the left, right? Because that negative got in the way. So that's why we factored out the -1. So whenever there's a negative in front of the x, I'd recommend taking out a -1 out of the absolute value, or you should be taking out a -1 from the absolute value. And this was our answer, and you can see that does move it 3 units right. So that's why it's important to factor out that -1 to get this one, rather than keeping that negative and then just minusing 3, because then the negative sort of changes things. Okay, but if I were to switch the order, say I wanted to translate it 3 units right and then reflect it in the y, well, translated 3 units right, that'll be -3. And then it's reflected in the y. If you do that second, then you make just the x negative. So then if I put it here, that does exactly what we wanted to do, right? We translated 3 units right. Then if I reflect this over the y-axis, then this will be my answer. So you see the order changes the entire answer here. So whenever you have an x in front, factor that out. And we'll look at one last one. So for this one, pay attention here. So we want to translate it 5 units up, followed by the reflection. So let's translate it 5 up first. So to do that, I'm just going to add 5 at the end. Right outside, that'll shift it up and down. Okay, and then followed by a reflection in the x-axis. And I know there, I need to make the entire function negative. So this entire thing needs to become negative. So the entire one, which means the negative needs to go to both here and here. So it's going to be negative x and then the plus 5 as my final answer. Okay, now let's look at that in the reverse order. So if I want to reflect it in the x-axis first, so if I have my parent function here, so that means I make the entire thing negative, which is pretty easy because it's just all I have is that. So make the entire thing negative and then translate it 5 units up. You could see we get sorry, I forgot to distribute the negative here. All right, so this minus needs to go to there, so that's minus 5. So you can see we do get a different answer. And if you looked at that visually, this one, right, so if I looked at this visually, right, so the first scenario we said translated 5 units up. So now it's the blue one up here, and then reflect it. So that means if I reflect across the x, I would want it to be upside down here, right? Do a complete reflection. So I'd have to make that negative. That's just going to flip it upside down, but then this plus 5 needs to become minus 5, which is why it's important to distribute that negative 5 it was set, but that'll reflect the whole thing down. Versus if I just make it negative and then translate it 5 units up, then it's up here. So you could see totally different functions if I switch the order. So the order is important here. Sorry for the mistake. I forgot to distribute there. Okay, let's just one point I want to make before we finish up here. So that point about factoring it out, just to show you. So if you reflect in this one in the y, which means you make just the x negative, so you make just this x negative. So that would be negative 3x, that would be negative 3x minus 5. Okay, so if you're doing that, just to make the point here, okay, so that 3x minus 5 looks like that red guy there. So if I make it negative 3x minus 5, so as you can see, we reflected it across the y-axis like we wanted. So that's what that negative x does. So think of factoring out, since there's a negative in front of the x, if I factor out a negative 1, then it would be 3x plus 5. Right, so we take away the negative 1, negative 3x minus 5. We have the same thing, just take the negative away from both of those, because then you could split it up, right? The square root of negative 1 and then 3x plus 5. And you know the absolute value, sorry, so the absolute value of negative 1 is just positive 1. So that just becomes 1. 1 times anything is itself. So you'll notice if you do 3x plus 5, you actually get the same thing. If I copy and paste this down here, you can see 3x plus 5 does in fact give you the same thing. The green is the same as the blue, if I hide it. So if you have a negative in front of the x, you can always take that negative out of the absolute value. And you'll get the same exact thing. Okay, let's look at some translating lines. So here we have the line 3x plus 4, right? Mx plus b, so we know that's the line. Okay, so remember the parent function here, parent function is the most basic one. You take away all the numbers. So if you take away the 3, take away the extra stuff, you just have f of x equals x, or y equals x. Right? F of x and y are the same thing. So once again, this is easy to graph because the y is the same as the x. Right, so when x is 1, y is 1. So 1, 1. When x is 2, y is 2. So 2, 2. So it's really just going up 1, up 1, up 1 over 1. Negative 1, negative 1, negative 2, negative 2. So the x and y are the same, negative 3, negative 3. So it's really just sort of splitting the coordinate plane in half there. So graphing the parent function should be easy no matter which one I give you. Okay, if I want to translate this 5 units down. Erase, let me just. Okay, so I know to translate 5 units down, I need to take my function and then minus off 5 at the end. Okay, which means I could do 4 minus 5. So 4 minus 5 would give me a negative 1. Okay, so it looks like if I translated 5 units down, we'll get 3x minus 1. Okay, however, if I want to translate it 2 units to the right, remember left and right has to be, if I look at my drawing, inside the parentheses with the x. So horizontal shifts has to be inside parentheses with the x. So if, so we have 3, do this in a different color. So we have 3. So that x I need to put in parentheses. So inside, as with the x, we wanted 2 to the right would be a -2. Okay, so that has to be inside parentheses with the x and then the +4. Okay, so notice same 3x plus 4, but if you're shifting left and right, it has to be inside with the x, which means we can distribute here. So that'll give me 3x minus 6 plus 4. And then -6 plus 4 would give me 3x minus 2. Okay, so it looks like that would be my shift. Okay, so this says describe this as another translation, because we said with lines, we did a horizontal shift. We went right here, left and right, to get this one. But you could also sort of look at this as in the other way as well, a vertical shift. So you could always describe it as both vertical and horizontal. So if you look at just the number at the end to go from here to here, you went from +4 to -2. Once again, the slope is never changing, 3x, 3x, 3x. So if you want to go from 4 all the way down to -2, that's also down 6, right? So this would also be down 6 units. Right, so if you just subtracted 6 here, 4 minus 6 gives you -2, right? You would get the same exact line. So you can describe this as 6 units down or 2 units to the right. You'll get the same exact line. So you could always describe these as 2 different ones. Last thing I want to cover is some basic graphing, just so we're okay with that. Okay, first one we have a quadratic, so that means the regular x squared. If you graph I'll graph just the regular parent function first. So if we look at, let me do some. Okay, so if we look at y equals x squared, means to get the y, if you read this, to get the y or f of x, you have to take your x and square it. So if you take my x value of 0, 0 squared, 0 times 0 is 0. Take my x value 1, 1 squared is 1 times 1. So 1. 2 squared, 2 times 2 is 4. So my output is going to be 1, 2, 3 up here at 4. And you could do the same in this direction, right? -1 times -1 is +1. -2 times -2 is +4. So that's where we get our parent function. Okay, so when we're translating or flipping this, the relation of the points next to each other is always going to be the same. So from the vertex, you could go up 1 over 1. You go over 2, up 4. You go over 3. 3 squared is 9, up 9. So you can graph the rest of the points in relation to the vertex when you're shifting this. So if I wanted to look at this one, so first one, this one's going to shift it upside down. So I'm just going to do a quick sketch and then we'll make it exact. So we're going to shift it upside down. So rough sketch there. And then it looks like it's this +3 is going to move it 3 to the left. So now it's going to be 1, 2, 3 over here. And then 1 unit up. Right, so +1 is going to move it 1 unit up. Okay, so now it's going to be here. So if I wanted to sketch the vertex here, now I could do an exact graph. So it's flipped upside down with the vertex here. Okay, so remember to get to the next one, you go up 1 over 1, but since it's flipped upside down, you have to go down 1 to the right one. And same thing here. And 2 squared is 4. So if you go over 2 and down 1, 2, 3, 4, that'll be here. And you could do 2, 1, 2, 3, 4 on this side as well. So that'll be there. And then you can see you have an exact parabola here. Okay, so it's going to be the same exact shape, same exact size, just flipped upside down and moved over. So graphing those 5 points, no matter what, no matter how I slide it, no matter how I flip it, will always be the same. Unless you stretch it or shrink it, really, I go over 3, down 9, the points will stay the same, basically. Okay, same thing with the absolute value here. So I have that V shape, right? 1, 1, 2, 2, 3, 3. So that V where it's up 1 over 1, up 1 over 1. So there's my parent function. Notice I'm being exact here. I'm going up 1 over 1 all the way on both sides, right? Because you take the absolute value of -3, you get positive 1, 2, 3, right? So it should be 3, 3, 2, 2, 1, 1, just sort of the same. Okay, so here we don't have any flipping, but it is moving it 1 to the right since it's negative. And then this is going to move it 4 up. Okay, so if I do this in a different color, we want to move it 1 to the right. So that's going to move this 1 to the right is here, then 4 up. So 1, 2, 3, 4. Okay, so I want to do the same V shape, but up here. So if I put my vertex here, we're gonna go a little up the graph, but I remember I still want to go up 1 over 1, up 1 over 1. So I want to do that same V here, up 1 over 1, up 1 over 1. We could sort of continue there. And go on that side, and then same thing over here, up 1 over 1, up 1 over 1, up 1 over 1. So that'll be over here. Okay, so this red one would be my function. So the green one's my parent, the red one is the shifted one in this case, and reverse on this one. So graphing these, same order of the points, just shift it around, or you can even flip this upside down, just go down 1 over 1, down 1 over 1, if there's a negative in front. So you could do any of your translations or reflections and keep the same order of the points.